Hey, this graphic here, you might have seen a representation of that in evolution. And we talked about when you're trying to outrun a bear. And do you need to be faster than the bear? The statement was you don't really need to be faster than the bear. You just need to be faster than whoever you're with so that the bear will catch them, you will escape, and everything's good to go, right? So it's taking this concept to the homeostatic grade 12 viewpoint. How do you know a bear is coming? So the bear is going to make sounds. It's probably going to have an odor. You'll probably see it. And all these things represent a stimulus that your body is able to detect. Your nervous system, which is a part of the homeostatic mechanism, but it's faster than the endocrine response, your nervous system will take the stimulus and it will bring it to your brain. Your brain will react saying, oh, we need to get out of here. Otherwise, we're in real trouble. And off you go. So this whole process, this whole homeostatic mechanism here is classic homeostasis. So I'm going to kind of go over this. I'm going to diagram this here for you. Now, as I go through the nervous system, because there's so much information, a lot of it I'm not going to teach. I'm going to focus on the things that I know traditionally are a little bit more complicated, and therefore you need a little bit more assistance in the learning, okay? And if there's something that I happen to skip, and it's just the PowerPoint, and I don't talk about it, and you need more information, please ask. I'm happy to give extra information. I just don't want to give too much to overwhelm you because it's a lot of information. And I know as a grade 12 with everything else going on, you don't need any more than what's necessary, okay? So, in terms of our homeostatic flow, you'll notice this is on the worksheet. I mentioned homeostatic flow. Stimulus, this is where we start. Just move my keyboard over here. Is it? Stimulus, okay. So many wires here, if you guys saw my desk. All right. Stimulus. So in this case with a bear, that might be the vision of a bear coming at you, or the sound as it's coming at you, the scrabbling on the ground. So a stimulus is picked up by a receptor. Okay, so I'm going to use this short form from a receptor, R with a circle. Now the receptor is very special. The receptor is able to take this energy, whatever it is, visual energy, sound energy, smell, and it's able to take that and it's able to transduce it. The event is called transduction. So I'm going to put it here under receptor because this is what a receptor does. It undergoes transduction. So it converts the stimulus from whatever stimulus energy it is into something called an action potential. And that's incredibly important. The receptor might also do one other thing. It also might amplify the stimulus because it's possible that the stimulus coming in is really weak. So if you're in a really dark room and there's a light, distant, like a few photons, hit your receptors, you might not detect it. And even if it does, it activates so few receptors, it needs to be amplified so your brain can detect it. So the process of making the stimulus stronger, this is amplification. So the amplification sometimes is in the receptor, sometimes it's not. Sometimes it's before or after it. After the receptor, the information needs to be transmitted to the brain or the control center. So I'm going to say CC here for the control center. And the act of getting it from the receptor to the control center, this is called transmission. Okay, that's typically through a nerve. The control center is your brain. And in the control center, we have two major things happening. We have the reception of the sensory stimulus. So this is called sensation. So this is where you detect that the apple that you bit into is, the sensation is red. That it's crunching. That it smells sweet. That it tastes sweet. Those are sensations. And then your brain makes sense of that sensation and it attaches meaning to it. And when it attaches meaning to it, that is called perception. right? So sensation and perception both happen in the control center. Once you perceive that this brown lug-a-lug thing making all the sound is a bear, then if I continue this, we'll get to the effector. In most cases, an effector is a muscle or a gland. And then the gland, the effector, will cause an effect. So this is not new. We talked about this at the beginning of homeostasis. Now I'm applying it to the nervous system. Stimulus, receptor, transmission, control center. Really, that's the main part that we're focusing on here. Everything that happens after is more motor responses, and that's not really the realm of grade 12. So in this diagram, I'm going to talk about, so when was Jace, my oldest, was younger. He's the same, 1 year older than you guys. We had a 3-way fireplace, and he didn't recognize the fireplace was hot, and we weren't close enough to stop him. And so he touched the fireplace, and he burned himself. He burned his fingers. And one of the things that your brain is really good at doing is it's really good at making connections to things that might endanger you. And so once you've hardwired these things that could endanger you, like something being extremely hot, then your brain doesn't need to process the information because it takes time. One of the things I'd like you to do, so you might want to pause the video here. If you've got a deck of cards, this is a great activity. With a deck of cards, you're going to take the deck and you're going to you have to do it one at a time. You're going to take the deck of cards and you're going to put them into 2 piles. Just 2 piles. But you can't do it 5 at a time. You have to do it 1 at a time. So 1 in each pile. Okay? You're going to time yourself, or someone's going to time you. And do that 3 times to get an average. Once you've done that, then you're going to put them into 2 piles of red and black, or whatever the 2 colors are. And then you're going to time yourself. And then you're going to do another one, a third one. You're going to put them into 4 piles. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And time yourself. Each time, if you can do 3 trials, that's perfect. If you can't, it's okay. And the last time, you're going to put it into 4 suits. So spades, clubs, diamonds, hearts. And you're just going to put it into 4 suits. So the act of doing this, you should notice that if you practice, that putting the 2 piles and even 2 colors, super fast, super easy. 4 piles, really easy. But once you get into suits, what's happening? The information is going to your brain. Your brain is processing what's happening, and then you are deciding, oh, this is a club, it needs to go in that pile. That's a spade, it needs to go in that pile. So that takes a little bit more thinking time, and therefore you slow down. If you're protecting yourself, if you're in danger, that thinking time can cost you, it can cost you a finger, or it can cost you something even more. And so for that reason, we have something called a reflex. Reflexes, instead of going to the brain immediately, they go to the spinal cord. And in the spinal cord, they are processed and you have an immediate reaction. So if something's hot, your spinal cord will recognize it's hot and withdraw your hand before your brain even knows that there's pain. Or if you touch something sharp. That's how reflexes work. So it's the same idea as what I just drew for you. Sensories, the stimulus comes in. Oops. Stimulus comes in. Sensory receptor takes it up. And then the sensory input is another name for transmission. This could be a very specific type of neuron, which I'll explain to you in a moment, goes to the brain, the control center, where information is integrated. You get sensation, perception is in the brain, but if you need a reflex, it just goes to the spinal cord, and then it tells your muscles to pull away. And that's your effector. So this is the reflex. And on the PowerPoint, you'll see more information about the reflex. Now, before I go too far, there's the parts of the brain. So as I said before, on the PowerPoint, there's a number of things that I'm skipping. On the PowerPoint, you'll notice there's a whole section that talks about the parts of the nervous system. So I didn't talk about that. Make sure you get that from the PowerPoint. I don't need to because it's very content oriented. I'm just going to focus on, to keep this video lessons short, I'm going to focus on the things that you need my help with. As you go through the learning, you'll notice that there's different types of members of the nervous system. We all know about the neurons, but do you know about the glial cells? The glial cells are non-neuronal cells, and they're very important. There are more glial cells than there are neurons. the neurons are very, they need a lot of support. They're high maintenance, and they can't do it all themselves. So the glial cells help, and there are different types of glial cells. Some glial cells are only found in the central nervous system, which is the brain and the spinal cord. And I'll show you the brain and the spinal. So here's the central nervous system, the brain and the spinal cord, and some are found in the peripheral nervous system, which is everything else. So for the brain is dumb, right? The brain is trapped in a skull, and that can't do anything without the peripheral nervous system. So through the peripheral nervous system, it's able to communicate with the outside environment. That's your senses and everything in between. Okay, so your peripheral nervous system and your central nervous system together require the help of these glial cells, of which there are several types. So on the PowerPoint, you'll see the different types. You can focus on that. I'm not going to. The one thing I am going to focus on is this thing called the myelin sheath. They are super important. There's a disease known as multiple sclerosis. I don't know if you've heard of it, but in multiple sclerosis, you don't need to see me anymore. So I'm going to take my camera. I'm going to pause it here. So with multiple sclerosis, it's an autoimmune disorder. Your body attacks itself, kind of like diabetes, where the body attacks the pancreas, or rheumatoid arthritis, where the body attacks the joints. In multiple sclerosis, your body attacks the glial cells that surround and support the neurons in the brain and the peripheral nervous system. And so what happens is the glial cells get attacked, and those persons, they start to get tremors. That's kind of the earlier signs, and then they start to lose control of certain parts of their body, and eventually it typically leads to death when you lose control of your heart and some of your important organs inside your cavity here. So the glial cells are the reason why that happens, because they get attacked and destroyed, and we'll talk about what they do a little bit later. But in terms of anatomy, you're responsible for knowing the neuron anatomy. So if I were to draw a neuron for you, you'll see it on this graphic here. But if I were to draw one, we have your classic dendrite. That's over here on the right. And your classic neuron with these dendrites, there's multiple dendrites. The dendrites where the information comes from, right? So a dendrite's coming in. You got your cell body. Dendrite comes in. So the information's going this way. Right? The dendrites picked it up. So this represents your dendrite. It might go through the cell body. It doesn't have to. And then on the other side of the cell body, we typically have this one long extension of the neuron, which we call the axon. And that ends in this very special structure at the end. So this is the axon. And again, the information is going in this direction. It only goes one way. When it reaches the end of the axon, it's going to jump to another neuron, and it jumps to this dendrite, and it continues all throughout the nervous system. Okay, and that region here where the two neurons meet, that is known as a synapse, and we'll talk about that a little bit later. Okay, so if you look at the neurons, you'll see that here I've listed for you 3 major types. So you can record that on your sheet. These 3 different types are associated with specific roles in the nervous system. Okay, so you'll notice that one type is called the bipolar because it's got these 2 ends here that look equal. Unipolar is basically one long thread with a cell body at the side, and multipolar, which is the classic neuron that we see in a lot of books. So when we go into the neuron anatomy and the nervous system structure, you'll see that these particular shapes have roles. So the sensory neuron is the one that carries information from the receptor to the control center, right? And you'll notice that it has the unipolar shape, right? Unipolar shape, with the cell body up to the side. The motor neuron often has this multipolar shape, where these multiple dendrites are coming in from all these different places, goes to the cell body, and then one long axon that goes to the muscles. And the bipolar, you'll see it in a number of different places. So these three neurons here, sensory, motor, and interneuron. I'm going to go back to that initial diagram I made up for you. So when a stimulus is brought to the receptor, so the stimulus and the receptor, you know, it's the eyes, the ears, your sensors also inside your body. Your receptor then has the information, it transduces it to an action potential. This very first neuron, this is your sensory neuron. Then within the control center, there are many neurons. And these neurons here, I'm going to represent with this line. I guess I'll use blue now. So within the control center, there's going to be a neuron. And this one here is called an interneuron. And then finally, out here on the far side, we have our last neuron. And this one here is your motor neuron. Right? So it's still the same information. I'm just superimposing more things onto this diagram. Sensory neuron to the interneuron to the motor neuron. The motor neuron goes to the effector, and the effect is done. Okay? So that's your basic structure of your neuron. And as I mentioned before, your neuron will go all the way to the end. And at the very end, you'll meet this thing called the synapse. And the synapse is where one neuron talks to another neuron. The axon of one neuron talks to the dendrite typically, or the muscle of another cell. Okay. Now, the question is, what happens on the inside? How does information move along this neuron from point A to point B? And that's what we're going to get into next.